My background is in evolutionary biology. When I started my PhD around 2000, I started becoming more and more interested in immunology. There was just not a whole lot of research on the immune systems of wild animals, and I sort of jumped on this train of ecological immunology, which mostly meant thinking about the immune systems of wild animals while they're out in the field doing their regular day-to-day activities. So I pursued that discipline for the 5 years of my PhD, and then I started here at USF in 2007, seeking to pursue this growing field of ecological immunology, but trying to move more in the direction of how does this influence the dynamics of infectious diseases that have relevance to people. So this project is just basically, how does the size of an animal influence its immune system? The physiology, body size, just how big you are, is one of the best predictors of how things live. The total number of heartbeats that an organism is going to have is going to be the same throughout its life, but the way that it spends them is completely different. Mice have incredibly high levels of heart activity, and elephants really not so much. Wouldn't it be cool if we could go into any system that we've never been before, and just based on measuring, about the easiest thing it is to measure, how big something is, we would get some sense of the risk that that thing poses on transmission of diseases in that community, or the risk of transmission of diseases to us. What's so cool about body size as an organizing principle is that if it fundamentally influences the way that life works, and if life exists in other places in the universe, then we might know something about the ways that life that we discover elsewhere interacts with other life. That's a pretty powerful type of thing. And again, that's a massive overreach to what we'd really be able to do. But it's the spirit of where a lot of biology is really trying to